And now we will have the presentation from Xavier Maréchal. The title of the presentation is An Actuarial Engineering Perspective, Why Actuarial Science and IT Skills Must Converge. Xavier, please. Xavier holds a master in actuarial science. He is the founder and the CEO of the consultancy firm ReactFin. And his main field of expertise is non-life and health insurance. He's one of the co-authors of the book Actuarial Modeling in Claim Counts. And he's an active contributor to the Institute of Actuaries in Belgium. So, Xavier Maréchal, Xavier, you have the floor.
Thank you. So my presentation will be rather high level, so no formulas. If you are expecting mathematical formulas, you have a few seconds to go to another room. But what I want to try to do today is to give some reason why actuarial science and IT should somehow converge. And we should have some, what I call actuarial engineers that might be the bridge between actuarial science and IT. So this is me. And first, I was not very original, I asked ChatGPT what are the new IT skills that actuary should have or should develop. So there are basically three, let's say, topics, three main topics. You have, let's say, skills related to data, so data management, data engineering, big data technology. Then you have skills more linked to the modeling, which is, of course, the historical core business of actuaries. So using advanced techniques like machine learning for the modeling and automating this modeling process. And then you have some skills that are very IT specific, like cloud computing, API integration, data security, etc. So I found that the answer was a bit too much towards IT, so I asked myself, but what is your view about this? And I still have the three main components, so data, model, and what I would call operationalization of the model. And the skills are slightly less IT-oriented. And so the idea of this presentation is to go a bit through these three main blocks, data, modeling, and operationalization, and to give you some clues about how your practice could evolve in the future. I'm pretty sure that some of you in the room are already doing great in this context, but for others it might give some new ideas. So regarding the data part, of course, you know that you know this expression, shit in, shit out, and so of course this is really important for actuaries to have proper data to start the modeling phase. And in fact, we are used as actuary to work with structured data, so in database, data warehouse, or whatever structured form. But in fact, in insurance company, it is estimated that more than 80% of the data available is unstructured. So it can be in documents, in emails, PDF, images, or whatever. So you have a lot of different sources that you can imagine. So clearly numbers that you are used to use, but also text, image, as I have already mentioned. And so if you want to collect additional data in order to improve your risk assessment, you might want to look into this new source of data. But of course, it increases the complexity to handle this data. And so you might want to have a look at, let's say, not traditional source of data. So data sourcing is really important. So you might want to look at data collected from the website with scraping techniques, for example. We discussed this morning in the plenary session also the increase availability of open data, and so you can find a lot of information provided by the governments, for example. Obviously, you have new techniques to collect data like IoT, so for example in telematics or API technology. A lot of external providers are now specialized in providing specific data to insurance companies. So there are a lot of different sources, but also I think you could look twice in your own data. So looking at, in particular, in unstructured data that you might have in your company. And so I think that it's important for actuaries, thanks to their business knowledge and the use that they have to assess risk, the actuaries could be the driver to identify new source of data and try to put strategy in place to collect these new source of data. And of course, when you have this gross, let's say, data that you have collected from different sources, but you have now to apply some data engineering techniques in order to put this data in the form that you want, and typically in structured form that you can analyze with statistical or machine learning model. And so, in my opinion, that's also a good idea for some actuary to explore, starting from the right, to explore some new techniques, for example, image processing. Some of you have maybe already heard that insurance companies are now using photos of car claims in order to assess the amount of a claim, so automatically based on photo. But you might think about other application of these image processing techniques. In the middle, and probably it's a bit more important for actuaries because the first example was maybe a bit far from actuarial work, but in the middle you have a lot of techniques like text mining, natural language processing, and large language model, so basically ChatGPT and all other this other model that can help you collect data that are in textual form and to create structured data. So you can think about analyzing claims report, risk engineering report, collecting information to create new features in your database and better assess your risk. And then you have more classical techniques like statistics or machine learning or feature engineering that could be also interesting. And so, yeah, probably if you are a bit stuck on the left side, it might be a good idea to explore the possibilities that you have on the right side of this graph. Speaking about collecting data, when you have more data collected, more feature, you have basically two strategies. I would call it, the first one, I would call it the data scientist or actuary strategy. Great, we have more data, we can complexify our model, we can try to improve the predictive power of our model, that's great. But of course, in this case, there is a risk of overfitting. I will come back on this in a few minutes. So you have to pay attention. And then you have the other approach that is more the business, let's say, approach, that would say, okay, if you are able to collect external data, then maybe I can collect less data directly from my policyholder. So I can simplify the quotation process of my policyholder. So it's good news for me because as a business expert, I can simplify the way I can underwrite insurance. Okay, so of course you have to find your way in these two situations. Another problem when you have a lot of features, a lot of data characterizing your risk is that you have also to apply some feature selection techniques in order to identify what are the most relevant variables. Of course, there are a lot of techniques. I don't have time to go into the details in 20 minutes, but this is something you might want to explore also. And the last element is also thinking outside the box and trying to perform what I call feature engineering, and I hope that Raphael will understand what I mean by feature engineering. So what do I mean by feature engineering is trying to find the best representation of my data in order to solve my problem. So let me give you a dummy example, and it's really stupid, but it's to make sure you understand. So let's assume that I want to model the frequency in function of the age. I have here the data point that I observe in my database. Of course, here we don't have many data points. And basically, to try to model these data points, but I could first start with a simple model. For example, a linear regression here. So it's a really simple model, but you see that it's not very good. So I want to improve my model, and I have basically two ways to do it. Let's say the traditional actuarial way will be to complexify my model. Okay, so I will use now a nonlinear model which will better capture my the pattern in my data. Okay, so of course this is a good decision to try to complexify your model, but you might also want to explore another direction that would be to change the feature that I have. So try to find the best representation of my feature in order to solve my problem. And so, for example, here, if you take the square of the age, but you can use a simple model like linear regression that would fit rather well your new adapted feature. Okay, here it's really a dummy example, but you can try to identify the best feature that would solve your problem. And then when you think a bit outside the box and you are able to identify what would help me to better assess my risk, of course, then the difficulty is to find the good way to collect this information or to build this information from the data that you already have. Okay, so here, that feature engineering, I think it's a technique that is not sufficiently used by actuaries. So this was for data. The second topic is modeling. Obviously, the topic you are probably the most at ease with. So clearly, machine learning techniques and AI are a hot topic for a few years now, and more actuaries are using these techniques that are very useful and very good. But I want to stress two things about the use of machine learning techniques. The first one is, of course, that machine learning techniques are usually black boxes. So you do not really understand how the model is calibrated, yes, but what are the impact of my different feature on the prediction? So this is really a problem. Another challenge is overfitting. So what do I mean by overfitting? Probably you know that from your statistical course at the university. But overfitting is, of course, when you complexify too much your model, and your model will then capture the noise that you observe in the data rather than the underlying pattern in your data. So here, for example, if you have a few data points, once again, you can use a simple model, but that will not fit well your data point. And you might want to complexify your model to better fit your data point. So you will reduce the bias of your model, but the problem in this case is that for new data points that were not in the database, you see that your prediction will probably not very good, okay? Because you have captured the noise in your data rather than the underlying pattern. And so it might lead to some difficulties and to some low predictive power. And so, of course, the idea is to find the right trade-off. And there are a lot of techniques. Unfortunately, I don't have time to go into the details to reduce overfitting, like having a training and test set approach or cross-validation techniques. So this is something you have to have in mind when you are using machine learning techniques. The other things, and it was already treated in this morning rather extensively, is the explainability or the interpretability of machine learning techniques. Because, of course, as you increase the complexity of the models going through a neural network or GBM or whatever, but it makes the model less transparent. And obviously, it is really important as actuaries to make sure that the results of our model are transparent, because we can understand, let's say, the mathematical details behind the model. We can convince ourselves with some goodness of fit statistic or whatever that the quality of the model is good. But you also have to convince other stakeholders that are maybe less quantitative than we are. And it's important to convince them to take sound decisions. So at the end of the day, I think you should find the right trade-off between predictive power of your model. Obviously, I don't say that you have to develop bad models, but to find a trade-off with the capacity to understand the result of the model and to take sound decisions. So to really find a trade-off. And sometimes, when it is really important to understand the result of the model, it might be useful to use a simpler model. So each time, ask yourself, who will use the result of my model? What is the purpose of this model? And what can be the potential impact? OK, so I have more or less 5 minutes left. So I will switch to the last topic, so operationalization of this model. So obviously, when you have developed models, you don't want that it's just a prototype that is not really used in practice or it's not efficient, etc. So you might want to improve the operationalization of the model. And this is something we have seen a lot for different clients we have worked for, is this struggle with efficiency, difficulty to introduce new data in my model, difficulty with performance, for example, with stochastic models, security problems, etc. And of course, it can lead to practical difficulties, not errors, or not being able to provide the result on time, etc. And so, in my opinion, it's important to improve globally for actuarial and data scientist team to improve the governance and the way we, let's say, the governance techniques that we put around the model development and the operationalization of this model. And there are a lot of tools that are useful. I will go quickly through the tools. You will have the slide afterwards. That you might want to explore. I have no time to explain in details, but here there is, for example, the Git and GitHub tools that are really useful for versioning or for working with several persons on the same model or on the same application. You have no AI copilots that can also help you to produce more automatically codes that will propose codes when you start typing. So these tools are really useful to improve your governance and your efficiency. There are also other tools like Sphinx, for example, that will allow you to produce more automatically documentation about what you are doing. And this is obviously very important because this is usually the last thing we do, documenting the code that we produce. And then you are somehow forced to do it in order to be able to produce automatic documentation. Another tool that might be useful if you want to better structure your pipeline from data sourcing to result, to producing result is the use of Jupyter Notebook. This is basically a web page where you can write some code. You can produce the result that will be in the same document with some comments that you can add. And it's a way to somehow structure your analysis and to be able also to share your knowledge more easily with other stakeholders. Another element, a bit more IT-oriented, is Docker, or the container in general. There are a lot of different solutions than Docker. Is to solve the problem when you are using, for example, R package, and the version of R is changing, or the version of the package is changing, and your application is not working anymore. With container, you can somehow build environments that are working by themselves. So you load all the package or your R environment, for example, and so it ensures that it will last over time and that it will still work in the future. Then you have a lot of tools for dashboarding, reporting, like RShiny, Dash for Python. You have vendor tools like PowerBI, SAS. Also, you can do a lot of things in Excel, of course. And then the last topic, I go fast in the last few slides. The last topic is API. It's a bit more IT, but it will allow you to collect automatically and sometimes in real-time data from other stakeholders, and also to feed system, for example, also automatically if you want to externalize your pricing engine, for example, because it's too difficult to introduce that in your system. So I'm at the end, the conclusion. So before my conclusion, I want to promote for 1 minute the JOCO in Brussels. I take this opportunity. So the JOCO is the first joint colloquium of all EAA section that will take place in Brussels end of September. So it's a 3-day event. We'll have more than 150 speakers on different parallel sessions, between 6 to 8 parallel sessions. And so if you want to be part of this great event and also discover Brussels, if you don't know, but do not hesitate to register. It is still, the early bird are prolonged until mid of June, so you can easily find, by Googling JOCO 2024, you can easily find the website and the program and the registration. So my conclusion is that, of course, technology is evolving very fast, and it's not easy to follow everything, and I won't advise you to try to follow everything. But I think that there is a sweet spot for what I call actuarial engineering to make the bridge between business department, actuarial department, and IT department, because I don't know how it works in your company, but I've seen in a lot of companies that there are really two separate departments, and it's not easy to work together. And so I think that actuaries, with their business knowledge, if they are able to develop also their IT-oriented skill, there might be a good bridge between these two department, business, and IT. So this is it for me. If you have some questions.
Thank you, Xavier, also for fitting to the time. Okay, any question to Xavier? Yes, please.
Hi, I'm Dan. I work in the London market. We don't have a lot of data, and a lot of our models are in Excel. And I think there's a general consensus within the profession that you're right, we want to upskill, we want to move to coding languages. But we often get risks in that don't quite fit the model. So if we had done something in Python, we would have this huge amount of Python infrastructure that we would need to change on an ad hoc basis for one particular risk. do you have any idea solutions to how London insurers might be able to approach that sort of situation as they try to move away from Excel?
So if I don't understand well your question, you try to go from Excel to Python, but you have difficulties. Sorry, I didn't get really your point.
Yeah, so when we talk about IT skills, like it allows us to be more efficient where we have a lot of data and we have the same processes. But there are some insurers who don't necessarily have risks that are so homogeneous. So we want to move to something that's a bit more efficient like Python, but we struggle. And I wondered if you had any ideas of how insurers might be able to move away from things like Excel, doing ad hoc modeling.
Okay, yeah, thanks for the question. Of course, the key thing there is to create awareness in the management and to put in evidence the risk that you might have to stick to Excels, the error that you can perform because you are copying values from one sheet to another. Of course, there are already possibilities to improve the processes in Excel, but what we have seen in projects that we have done in the past is that, of course, at some point you are still limited with what you can do in Excel, in particular when you have processes that are extensive in terms of runtime. And so, indeed, the first point is really to create awareness and to put in evidence the risk and train people to get used to this evolution. But it takes time. I know from experience that insurance companies are big boats, and it takes time to change direction. So, no specific clue. Sorry.
Any other question? I have one question. I think it's a practical question. If I want to start using machine learning techniques for my job, which ones should I first explore as first options?
Yeah, that's
because you presented a...
Yeah, that's a good question. I didn't went too deep into the presentation of machine learning techniques, and we could speak about that for hours or days. But typically, my experience is that it's probably better to start with tree-based models. So you see here a decision tree. They are easy to understand because if you have not so many leaves in your tree, you can understand what happens. And building on this regression tree, you can have a random forest, for example. And these models are quite easy to use. There are a lot of packages in R, Python, in order to use this model. If you want to go further and go to neural network, deep learning, probably you will improve a bit your predictive power, but it's really more difficult to put in practice, and it's also a bit less transparent than other models. So I would propose to go to a random forest first.
Thank you. Thank you very much, Xavier.
Thank you.